We're going to continue topic 3.1, the chain rule. So this is the official chain rule kind of theorem. So what happens is with the chain rule is we have an inside function and an outside function. So if we're given that y equals f of g of x, then we know that the derivative of y with respect to x is the derivative of the outside function, leave the inside function alone, times the derivative of the inside function. Sometimes instead of writing the g in there, they will represent the function on the inside with a u. So you'll see a lot of our derivatives written as f prime of u times u prime. We use the chain rule with composite functions. We look for stuff inside parentheses. We still only take one derivative at a time. We take the outside derivative first, leaving the inside the same, and then we multiply by the derivative of the inside. And then these are just kind of some guidelines, so when you forget what you're doing, you come back to this box. So first we rewrite the function with no radicals or variables in the denominator unless we're using the quotient rule, okay? Then you identify the stuff inside the parentheses, set it equal to u. And we're going to do that in the color orange. So that step is going to be an orange step for us when we do this. So you're going to probably want some colored pens or pencils or something. Write the function in terms of u using the substitution above. Differentiate using the chain rule. Take the outside function's derivative, leave the inside unchanged, then multiply by the derivative of the inside. Write the final answer in terms of the variables and simplify if needed. And watch out for e with exponentials. The exponent is always the function. So when I think of decomposing composite functions, I think of the inner function, u equals g of x, or whatever it is, f of x, and u is the bubblegum, u equals g of x is the bubblegum center of a Charms blow pop, okay? The outer function is y equals f of u. I don't know why I have this twice. These should not be twice. That's a typo. I apologize. As being the candy shell. So the outside function is the candy shell. The inside function is the bubblegum center of a blow pop. All right. So we're just going to look at, in this part here, rewriting these functions using parentheses, and then identifying what is the bubble gum and what is the candy shell. Okay, I don't know what happened. I have a typo here. I copied and pasted and I missed something. So there should be another part of our chart. We're going to rewrite with parentheses just in the original there. This is going to be the u equals g of x, which is the bubble gum. And then this is going to be y equals f of u, which is our candy shell. So let's just get used to writing that. So my parentheses would go here, right? So my u part would end up being x plus 1. And that means that the outer part of my function, so y equals, this would be u, right? Because I would replace this with the u. And then really it's got an exponent of 1 on it, so I would bring it upstairs and make it to the negative first. All right, the u in this one here, my parentheses would be there, would just be 2x. So y would equal sine of u. All right, my parentheses should go here. So my u would be 3x squared minus x plus 1, meaning that my new y equals would be the u, because that's what I'm going to replace this with. And then I'm going to have the square root, I'm going to convert it to the 1/2 power, so it's easier to take the derivative of. This next one is crazy. We're going to rewrite it as y equals tangent of x squared. That's another way I'm allowed to write that piece of trig. So my u, it's actually kind of hidden and weird. It's actually the tangent of x, meaning that my new y would be u squared.